Next up, we have iLEAD Consortium, California, Team 2, a Mission 11 flight experiment.
Hello, and the main question for a project is, does Saccharomyces cerevisiae go faster in microgravity or Earth? Saccharomyces cerevisiae, or whatever it's called, is common yeast that you can just find at like a Fleischmann's package at the grocery store. It can be used for bread, wine, and other things that you can usually find in your house. The idea came from my fridge. My dad has an instruction list on how to make pizza, which included yeast. So I said, hey, that may be a cool idea. For the next 2 slides, I would like Alexi Vilmar to do the next steps.
Since we are sending yeast, we need to know why. Why are we sending yeast? Well, space for applicants for space travel. Number 1 applicant is food and nutrition in space. Yeast is used in a lot of food, mainly bread and alcoholic beverages, as he said. And for nutrition, some strains of yeast is used for nutritional supplements. And also, we could also use yeast for fuel. Since you can make yeast into ethanol, you could make ethanol. Ethanol is used for fuel. And finally, for medicine, since you can make alcohol out of yeast, you could make alcohol as a disinfectant. And it's also, if we send yeast, like small samples of yeast into space, it will be a lot cheaper to grow than to send bigger packs of yeast. Now, materials. Next is a small list of what we'll be using. We're going to be sending 1 milligram of yeast. S-cerevisiae is basically a fancier way of saying it. It's also a type of yeast. And we're going to be using 10% of neutral buffered formalin, and that's going to be used for stopping the yeast from growing. And we're also be using YPAD. It's a shorter way of saying yeast. And now, Dan.
Our procedure was we used a type 3 FME tube. It has 3 sections. The first section is formalin. Formalin is a food it's to stop yeast from growing because it reproduces quickly and it stops. And the second section is just yeast. And the third section is yeast food. And when it arrives on the National Space Station, we will open the second clamp, and the second section and the third section will connect, and it will grow. The yeast will start to grow. And the second day of arrival, we will open the first clamp to stop it growing. We had some challenges during the process, and it was the size, what we needed, the amount of yeast, what we struggled with. Our weight was, we were going to use 2.4 grams. It was 2.4 grams, and we thought that was way too much. So we used 100 milligrams to 50 milligrams to 1. And we only use a little bit because we couldn't measure it or weight it because it's a small amount. So we used 1.
Okay, in this picture, we were checking if formalin would damage the yeast because Susan J. Basurga, a biophysicist at Yale, gave us a tip that it might damage the yeast. So we tested it with help of 250 students in our middle school. We had 125 tests that were controlled and 125 tests that were experimental, with ultimately no damage observed. when the experiments come back, we will put them into hemocytometers, which are slides for microscopes that have grids on them, so it's easier to count. And when we look at them under the microscope, we will check if there is more or less. And if there is 10 times, then if there's 10% more yeast on the space flight experiment than on the Earth experiment, that is our number to prove that it grew more.
We would like
to give special thanks to these people. They helped us a lot with.
Does anybody have questions?
Hi, I'm Deb. I'm from East Lyme, Connecticut. My question is, when you were running your tests or trials, did you do any of them in the actual FME tube? Because we had a group in East Lyme that was testing with the yeast, and although they were having a lot of fun, the end caps of the tube just kept blowing off every time they put the yeast in.
We did not have the ability to test the FME tubes because we were on a low budget.
Okay.
So we did testings in like the test tubes and other stuff like that.
Okay. Well, I hope that doesn't happen with yours.
I'm Catherine from Boise, Idaho, and I wanted to ask what made you choose S. cerevisiae, right, instead of other strains of
You
yeast?
can just say yeast.
You just say yeast. It's way better.
Thanks.
Like I said before, my dad works with fish tanks a lot, and he uses like a Pepsi bottle to hold with yeast to make the carbon dioxide for the fish to live. So he came up to me one day and I told him about the SSEP, and he said, "Hey, you should do it on yeast." And look where we are now.
Thank you.
Andrew from Buffalo, New York. First of all, I want to thank you, because I'll speak for the adults in here. If we do go to space, there needs to be things like beer and bread. So thank you.
We're gonna say that.
My question is, what do you think will happen as far as the effect of microgravity on the yeast?
Well, we are hoping that there is a 10% difference. We don't know which way, but if there's a 10% difference, that will really help with the experiment. If it's like under like 5% or something, we won't really need to do that.
Are you basing that on your research?
Yes.
Okay.
That's it? Is that it? Yeah, okay. Bye.